What if the biggest mystery isn't what falls into a black hole, but the chance that you might already be living inside one? For your whole life, you've heard that black holes are the universe's ultimate destroyers. The final stop, the end of the line, like a cosmic sinkhole with the drain pulled out. But what if that's not the whole story? Today, we're exploring the mind-bending theories suggesting everything we thought we knew about black holes might be wrong. First, let's cover what we all think we know. When a truly massive star, way bigger than our sun, runs out of fuel, it collapses under its own incredible weight, picture crushing the entire Earth down to the size of a single sugar cube. The gravity of that object becomes so intense that it literally punches a hole in the fabric of space-time. That's a black hole. Its boundary is called the event horizon, a true one-way door. If you cross it, you aren't coming back. Not even light, the fastest thing there is, can escape. According to Einstein's theory of general relativity, deep inside is a singularity, a point of infinite density where every law of physics as we know it completely breaks down. For decades, this has been the story. Black holes are the apex predators of the cosmos. They roam the universe, swallowing stars, gas, and anything that gets too close. They are endings, full stops, destructive forces that exist within our universe. But here's the twist. What if that's the wrong way to look at them? What if they aren't just in the universe? What if a black hole is the universe? The story we tell about our own cosmic beginning has a strangely similar problem. We call it the Big Bang. The idea is that our entire universe, all the matter and energy in trillions of galaxies, exploded from a single point of unimaginable heat and infinite density. A singularity. Sound familiar? For physicists, this has always been a huge question mark. A point of infinite density isn't a real physical thing. It's what happens when your math breaks. It's like an old mapmaker drawing "Here be dragons" at the edge of the known world. It's a warning that our current theories can't go any further. What came before the Big Bang? What lit the fuse? Science doesn't have a concrete answer. We have powerful ideas like cosmic inflation, but even that doesn't explain the ultimate origin. So, we have one story about black holes that ends in a singularity, and another story about our universe that begins with one. Both are points where our understanding of physics hits a wall. But what if they aren't two separate problems? What if they are connected in a way we never expected? This is where a fascinating, though highly speculative idea comes in. It's known as black hole cosmology. Championed by physicists like Nikodem Popowski, this theory suggests that our universe didn't just pop out of a void. Instead, it might have been born from the collapse of matter inside a black hole in a much larger, older, parent to your universe. The thinking goes like this. When a massive star in that parent cosmos collapsed, it didn't just form a dead-end singularity. Instead, the mind-bending physics inside the event horizon triggered a rebound. Imagine squeezing a coiled spring down as tight as it can go. At some point, it can't be compressed any further and violently expands outward. This big bounce would have given rise to a brand new, expanding space-time within the black hole itself. In this model, our universe isn't some isolated island. It's a nested reality. To anyone in that parent cosmos, our universe would just look like a regular black hole. But for us, on the inside, it's everything we can see and touch. This isn't just a wild thought experiment. It offers a strange new lens to look at some of cosmology's biggest puzzles. Okay, this might sound like it's straight out of science fiction, but proponents of this idea point to a few interesting clues. First, there's a weird mathematical coincidence. If you calculate the mass of our observable universe and then figure out the size of a black hole with that same mass, its Schwarzschild radius, you get a number that is surprisingly close to the actual measured radius of our observable universe. Think of it like finding two strangers from opposite sides of the world who have the exact same, incredibly rare fingerprint. It could just be a wild coincidence, and most physicists believe it is, But in science, coincidences like this sometimes point to a deeper connection. The immediate question is, of course, if we're inside a black hole, why aren't we being stretched into spaghetti? That terrifying image of spaghettification is what we all imagine, but that really only applies to smaller black holes. For a black hole the size of the universe, the tidal forces would be incredibly gentle. Imagine an ant walking on a beach ball. The curve of the ball is so gradual that to the ant, it feels perfectly flat. You could cross the event horizon of a universe-sized black hole without even knowing it. You wouldn't feel a thing. But the most clever part of this theory is how it tries to solve the singularity problem. According to Popowski's work, which adds a concept called space-time torsion into the mix, matter collapsing inside a black hole would never actually reach infinite density. Instead, these torsional forces would act like that powerful spring we mentioned, pushing back against the crush of gravity. Matter would reach an unbelievable, but finite density, and then bounce outward, creating a new, expanding universe. Suddenly, the Big Bang isn't a beginning from an impossible point of nothingness. It's a big bounce, a physical event that could, in theory, be a natural part of a cosmic cycle, turning an end into a new beginning. If an idea like this were true, it would completely reshape our place in the cosmos. Think about it. If our universe was born inside a black hole, what about the billions of black holes we see in our own universe? Following this logic, every single one of them could be a seed, potentially giving birth to a new baby universe on the other side of its event horizon. This paints a picture of a vast, fractal-like multiverse, a cosmic family tree of universes nested inside black holes, which are themselves inside other universes, on and on. It's a concept that some have called a Russian doll universe. For a long time, this was pure speculation. But the theory makes a specific prediction. If our universe was born from the collapse of a spinning object in a parent universe, it should have inherited that spin. Recently, some studies have found something perplexing. Looking at data from large galaxy surveys, computational astrophysicist Leo Shamir reported a strange asymmetry. He found that more spiral galaxies seem to be spinning in one direction than the other, an imbalance that shouldn't exist if the universe was truly random. As he stated, the lopsidedness is there in the data. Now, to be very clear, this is a controversial finding. Scientists are cautious, and this could be the result of some observational error or an effect we don't yet understand. It is far from proof. But if this observation holds up after more scrutiny, it would be a powerful hint that our universe might have been born rotating, just as black hole cosmology suggests. We started this with black holes as cosmic graveyards, the final chapter for anything that falls in. We end with the mind-bending possibility that they are cosmic wombs, the first page of everything we see around us. This theory offers a potential, though unproven, solution to the singularity problem and gives a physical story for the Big Bang. It reframes our entire existence, suggesting we are not in a universe that simply has black holes, but that we might be living inside of one. We aren't just looking out at the cosmos, we might be the cosmos, looking out from within. The question is no longer just, what's out there? But what kind of universe are we in? If this video challenged how you see reality, hit the like button and subscribe for more journeys to the edge of what we know. What do you think about this idea? Let us know in the comments below.